Hello, in this video, we will begin to introduce ABO trees in chapter 5. An ABO tree is a balanced binary search tree. In chapter 21, we introduced the binary search trees. The search, insertion, and deletion time for a binary search tree depends on the height of the tree. In the worst case, if all the nodes are in one line from the root to the leaf, the height is order of n. If a tree is perfectly balanced, it's a complete binary tree, its height is log n. Can we maintain a perfectly balanced tree? Yes, but it will be costly to do so. The compromise is to maintain a well-balanced tree. That is, the heights of two subtrees for every node is about the same. That is the ABO tree we're going to talk about. ABO trees are well-balanced. In an ABO tree, the difference between the heights of two subtrees for every node is 0 or 1. It can be proven that the maximum height of an ABO tree is order of log n. The process of inserting or deleting an element in an ABO tree is the same for a regular binary search tree. The difference is that you may have to rebalance the tree after an insertion or deletion operation. So now we define the balance factor. Balance factor of a node is the height of its right subtree minus the height of its left subtree. For example, for this 45, so there is no right or left subtrees. So the height is 45. For this node 55, there's no right subtree. And there's one here, just one. The left subtree has only one node here. So the height is -1. So look at this, 60. So what is the height? You can see this is the height of its right subtree is one more than the left subtree. So that's why it's 1. So the height of the right subtree minus the height of the left subtree is 1. So look at this 100 here. The height of the right subtree minus the height of left subtree is -1, but because this on the left is one more higher than on the right. So let's use this animation to see how we rebalance the tree here. So this, right now, this tree has 4 nodes. This is an ABO tree. So you look at every node, the balance factor is either 0 or 1. All right, so now I'm going to add 31 here. So if you add 31 right here, so what happens? It's going to cost this 25, the balance factor, to be +2. So the right subtree here, this is, the height is 2 more than the left because there's nothing on the left. So this is going to be 2. So that is not balanced. So we need to rebalance it so that the entire tree is an ABO tree. So this is what happens. You're going to see the rebalance is you are going to have the 31 here. 31 here and 25, 35. So let's continue to add 1 here is 75. So there's no problem. You put 75 right here. You don't need to rebalance. It's right here. So you add another one, 45. There's no problem here. 45 will not cause any problem for all these nodes here. 45 is going to be here. But when you add one more here, 50, let's look 49. So this will cause 35 to be unbalanced. The load factor for 35 will be positive 2. So in this case, you need to rebalance it. So rebalance it, and you're going to see this is going to be 45 is here, 35, 49. All right, we're going to look at the algorithm for ABL tree. How do we perform insertion and deletion and rebalance and afterwards, and so that the new tree is still an ABL tree. See you on the next video.